start back with 66 over again. So for problem 66, it tells us to state if the triangles in each pair are similar. If so, state how you know they are similar and complete the similarity statement. So we have 3 different similarity conjectures that we could use to test whether triangles are similar. So what's one of our conjectures? Side, side, side similarity. What else do we have? Angle, angle similarity, and side, angle, side similarity. Very good. All right, so for the problem 66, what do we need to label in this diagram? What do we have that we need to label? What kinds of angles do we have?
Vertical.
And vertical angles are always congruent. Very good. So now that we know that we have a pair of congruent angles, we have vertical angles that are congruent, all right? We have how many pairs of sides? We know information about 2 pairs of sides. So what conjecture are we going to use here? Side angle, side similarity. So we're going to test this to see if they are in fact similar. So side angle, side. We need 3 bubbles at the top level because there are 3 letters in our conjecture. So let's start with the easier part. Let's label our triangles first. So between 63 and 91, the small side is 63, so the large side is 91. Between 45 and 65, the small side is
45.
So the large side is
65.
Very good. So now let's plug this in. So we've got 63 over 45. What does that reduce to as a fraction in lowest terms? 7 over 5. Very good. Now let's take our other side ratio. So we've got 91 compared to 65. What does that reduce to? Exactly, 7 over 5. So we know that we have the same ratio of our sides. Now, we have to show that we have the angles in the middle as congruent. Okay, we know that the angle between the 2 pairs of sides that are similar are vertical angles, so we know they're congruent. We just need to fill this out. Since they share a vertex, we're going to have to use how many letters to name the angles? 3. How would you like to name this angle up here?
MLK.
We can name it MKL or LKM. K has to be in the middle because K is our vertex. Very good. So if we did MKL, we have to do angle what for the other one? DKC, angle DKC. So it did work out with side angle side similarity. So we're going to draw our arrows down to our conclusion box. Draw our conclusion box. We need to finish the statement that they started for us. So triangle KLM is similar to triangle. So if we did KLM, we went along the long side and then down unknown side. So we're going to go along the long side. So triangle KCD. Triangle KCD. Record. For problem 67, do we have information about all 3 sides of each of the 2 triangles? Yes, we do. So we're going to use what conjecture? Side, side, side. So I have highlighted the smaller triangle just so we're clear about what we mean by the smaller triangle. Okay, we're going to use side, side, side similarity. So that means I need how many bubbles on the top level? 3. Okay, what number would you like to start out with? Okay, so 89 in the large triangle compares to what in the smaller triangle? 40. Okay, what does that reduce to? Does 89 over 40 reduce? No, so it stays 89 over 40. All right, we go back to the large triangle. So 73 over what? 32. What does that reduce to? Okay, we already know. Are these the same? Is 89 over 40 the same as 73 over 32? No. I'm going to go ahead and fill in the other one. We've got 99 over 44. What does that reduce to? 9 over 4. Wait, yeah, divided by 11. It's 9 over 4. So, none of these are the same, actually. Once you know that they're not all three the same, we know that the two triangles are not what?
Similar.
They're not similar. And we need to put down our conjecture, so we use side, side, side similarity. And actually, let's go back to problem 66, and let's write that we used side, angle, side similarity. Let's put that down at the bottom of our conclusion bubble. Okay, any questions on our flowchart so far?